This is KOPE, K-O-P-E, Parabola Solutions. And the parabola we're working with is 4, 3, minus 1, which is the I sub A, I sub B, and I sub C. And the equation is y equals f of x equals 4x squared plus 3x minus 1. There are 6,498 plus 1 solutions. Y prime equals f prime of x equals m sub x. And that turns out to be 8x plus 3. UF means use formula, D and UF means do not use formula. Arithmetic, use a calculator. There's a second bracket here. I sub A are the integers greater than or equal to minus 9 and less than or equal to plus 9. And I sub A is not 0. If I sub A were 0, we wouldn't have a parabola. I sub B and I sub C are integers greater than or equal to minus 9, but less than or equal to plus 9. When I sub A is positive, implies that you have a minimum of the parabola. When I sub A is negative, we have a maximum of the parabola. The intersection of the x-axis. You have no intersections when the square root of b squared minus 4ac has an I factor. We have one tangency, one intersection, when the square root of b squared minus 4ac is 0. And we have two intersections when when that square root has two real roots. Item 3. This is how to organize your 6,498 plus 1 parabolas. And you have a total of 18 arrangements. And these arrangements are set up under the plus 1 idea. And the second arrangement is under the minus 1 idea. So that you have 16 of these groups to organize your 6,498 plus 1 parabolas. This is your item 4. There are 9 steps for each solution. This is an illustration of what the 9 steps are. Step 1 is the value of y for any x. Step 2 is the change in the y value for any x, which is called f prime of x. And m sub x is equal to f prime of x, which is y prime. The axis, step 4, the vertical line through x0, the ordered pair x0, that divides the parabola into two equal areas. For A to find this axis, we use the formula x equals minus b over 2a, and the b part, do not use formula. We solve the equation m sub x equals 0, so that's where the x value is. Step 5, the roots are real or imaginary, and we use the square root of b squared minus 4ac for this idea. Roman numeral 5. Step 6, the minimum. Because I sub A is positive, we have a minimum. That's where m sub x is 0, and we solve for the ordered pair for the minimum. Step 7, the roots. You have used formula. We use the formula minus b plus or minus the square root of b squared minus 4ac over 2a. And the b part, do not use formula. We have these roots occur where f of x is 0, and this gives you a quadratic equation. Step 8, given the roots, solve for f of x equals 4x squared plus 3x minus 1 equals 0. And the roots, we're going to use the product x minus r1 times x minus r2 equals 0. Substitute in that equation. Step 9, graph y implies points greater than or equal to 5. You could use more than 5, but we're going to use 5 points. Step A, 2 points, is where f of x is minus 1. We have 1 point at the minimum point, and we have 2 other points at the x-intercepts. Step 6, this is graph 6. 4, 3, minus 1, we have This is the actual solution of the problem. So we use step 1 in the solution, y equals f of x, 4x squared plus 3x minus 1. We put down what y prime is, 8x plus 3, and m sub x is y prime, number 3. The axis, we use minus b over 2a, we get minus 3/8. Solving that equation for m of x equals 0, we come up with minus 3/8, and we circle them to show that they're the same. 5, we use the roots implies real or imaginary, and we use the square root of b squared minus 4ac. We use the plus of the square root. And we plug in the numbers, we come up with square root of 9 plus 16, which is 5. So that implies real roots. 6, we have, we're looking for the minimum. That's where m of x is 0, x is minus 3/8. We found that out in one of our previous steps. Then plugging in for the ordered pair x, y, we plug in that minus 3/8, we solve for the y, and that ends up with minus 3/8, comma, minus 1 and 9/16 as the minimum of f of x. 8 are the roots. The a part for a is using the formula. And plugging in the numbers in that formula, we come up with x equals a quarter, and x equals minus 1. Do not use formula where f of x is 0. We solve the quadratic equation where f of x is 0. 4x squared plus 3x minus 1 equals 0. And solving that equation, we take and replace x squared plus 3/4 x by x plus a half of that, which is 3/8 squared. But that's bigger than what we're substituting it for, so we have to add a 9/64 on the right side of the equation. So we ended up solving this equation. They both have the denominator 8 on either side when you take the square root of the right side. So we ended up with x equals minus 3 plus or minus the square root of 16 plus 9 all over 8. And that gives you x equals a quarter and x equals minus 1, which agrees with our use formula. Step 8, given the roots, solve for f of x equals 4x squared plus 3x minus 1 equals 0. And we use the formula x minus r1 times x minus r2 equals 0. And substituting in for the r1 and r2, we come up with our final solution, 4x squared plus 3x minus 1 equals 0. That agrees with what we're looking for, so we circle them, they agree. Step 9, with our graph, we're going to use 5 greater or equal to 5 points. We're going to use 5 points. We're going to use x-intercepts. We're going to use where y is minus 1, and the minimum point. And using the minus 1, we set the function, the parabola equal to minus 1, and that turns out to give us an equation 4x squared plus 3x equals 0. And to solve that quadratic, we just factor out an x, and we come up with x equals 0 and x equals minus 3/4. That's at our point where below the x-axis there, 0 minus 1 and minus 3/4 minus 1. And we plug in our points for our intercepts, 1/4, 0, and the ordered pair minus 1, 0. And we put in the minimum point, minus 3/8, comma, minus 1, 9/16. And that completes the solution of one parabola. And we have how many more to go? 6,498 more parabolas to go.